All right, so what we're going to do now is go backwards. Before we had a graph that we saw and we needed to determine and find certain parts and characteristics of it. Now we are given the characteristics and we go ahead and draw our own graph, our own function. In this first example, we're supposed to draw a function that has a local maximum at -2 and 5 and local minimums, two of them, at -4 and 0, and the other one is at 4 and -0. So our local maximum is at -2 and 5, in other words, up here. Our local minimums are at -4 and 0, and the other one is at 4 and -4. Now remember, local maximum is a point that looks kind of like it's on the top of a hill, and local minima or minimums look like they are at the bottom of a valley. If you indicate things like that, that will help you go ahead and graph your function, and this is how you can graph it. It doesn't have to be 100% exact, as we have only those 3 points of interest, but those 3 points of interest are where they are, and that gives us an indication of the general shape of that function. In our second example, we are not given the maximum and minimum. We are given information about the intervals. We know that there is an increasing interval between -infinity and 1, and a decreasing interval between 1 and 5. So let's first mark those points on our x-axis. 1 is the upper end of the increasing interval. We cannot mark the lower end because that's -infinity. The decreasing interval starts at 1 and goes to +5. Now we are not being told where that curve lies or how high it goes up, so all we know is we can go from here all the way up to our maximum, and from there we then afterwards go down and stop here at +5. We have no information about where that curve continues. Since we're stopping at +5, we need to give it an open circle. And with that piece of information, just so you're clear, we could easily have also graphed something that starts here and finds its local maximum here, and then goes down further from here. Both of those are perfectly fine. I just want you guys to realize that, because all the information we're given is that there is an increasing interval and there is a decreasing interval. All right. The last thing I want to discuss with you today is inverse. An inverse interchanges the domain and the range of the original function. In other words, we need to flip the x values and the y values, and in order to do so, we need to first start making the table of values. For the table of values, we're going to pick numbers which are right on the grid line, where our graph crosses the grid lines in a point where we can read the numbers off fairly easily. These 5 points work. So let's make our table of values. Going from left to right, we got the coordinates -2 and -3, -1 and 0, 0 and 1, 1, 2, and 2, 5. Now we flip the y and the x values to create a new table of values where x is negative 3, 0, 1, 2, and 5. Y is negative 2, negative 1, 0, 1, and 2. And these 5 coordinates, these 5 ordered pairs, we will use to now graph our inverse curve. Negative 3, negative 2, 0, negative 1, 1, 0, 2, 1, and 5, 2. This is how the curve looks when we combine those points. And remember from our learning objective, we said that this looks like a curve. And think back to your geometry classes when you talked about reflections. This looks like a curve which has been reflected along the line y is equal to x, which is the first diagonal of the coordinate plane. And as you put that into your coordinate plane, you see very neatly how those points have been reflected across that line. Let's look at our second example. We are going to start again by identifying points that work for our table of values. Again, always pick points that are where the grid lines cross. That way you get a clean reading on the coordinates. Going from left, we have negative 3, positive 3. We got negative 2, 0, negative 1, negative 1, 0, 0, and 1, 3. Flip the coordinates to create a new table of values. Now the x values are 3, 0, negative 1, 0, and 3. The y coordinates are negative 3, negative 2, negative 1, 0, and 1. We're going to go ahead and graph these. Positive 3, negative 3, 0, negative 2, negative 1, negative 1, 0, 0, and positive 3 and 1. And this is what we get when we combine these points. If you draw in your diagonal, you see, two of these points, also points on the original graph, were directly on the diagonal. That means that they remain the same for our inverse curve. And that's what you see clearly as you graph in the the diagonal. And the rest, you can again see that the red curve is reflected along that diagonal from the black curve. Now I keep saying curve, and it's because the red is not a function. You will remember from Algebra 1 what constitutes a function, and you will remember about the vertical line test. And if you think about the vertical line test, you can clearly see that there are many points, just one of them being the point here at x is equal to positive 3 that has two corresponding y values. And that is the reason why the red curve is not a function. Just a little refresher of what constitutes a function and what the vertical line test does for us. This concludes our second and last lesson of Unit 1, Characteristics of Functions. Please take a minute now to write your 20-word summary. Remember, 20-word summary doesn't mean that you cram in all the vocabulary that you saw in here. I want you to think about it, write 1 or 2 sentences, and describe in your own words the most important aspects of this lesson. Very well, excellent, and I will see you in class.